Hi everybody. Today we are going to discuss about static electricity. Static electricity. It's also can be called as electrostatics. Static electricity also can be called as electrostatics also. Its another name is electrostatics. Both have same. So first of all, let us know something about electricity. So you should learn what is electricity first. So electricity is not like a city which has city. So it is not a city like Hyderabad, Vijayawada like. So it has a complete meaning. Electricity is one of the branches of physics. In physics we have many branches like optics, mechanics, waves and thermodynamics. Similarly, electricity is also one of the branch. So suppose if you think that physics is a big tree, so this role electricity is one of its branch. So in electricity what we study? Let us think that. So in electricity we study about a hero called charge. We are going to study about a charge. So that particular study we are calling as simply electricity. So the branch of physics which deals with the study about charge is called electricity. Once again, the branch of physics which deals with the study about charge is known as electricity. So this electricity are of two kinds. This electricity is broadly divided into two groups. One is called static electricity, another one is called current electricity. So two types, one is static electricity and another one is current electricity. So in static electricity we learn about charge when it is at rest completely. When the charge is at rest, if you study about that charge, that is known as static electricity. Once again, static electricity is nothing but the study of charge when it is at rest is known as static electricity. Current electricity is nothing but the charge in motion. When the charge is in motion, if you study about that charge, that is known as current electricity. Understood the difference between static electricity and current electricity? Right, static electricity we deal with the charge when it is at rest. In current electricity we discuss about the charge when it is in motion. Right. So let us start our static electricity. So we should learn about charge first. This is all about charge only now. So that we should learn about charge. What is charge? So it is very difficult to define charge like mass. So we cannot visualize mass. So this, for example, let us say this pen has a mass of 100 grams. Can you visualize its mass? No, it is nothing but a plastic. So we cannot visualize its mass. So mass is defined by the scientist Newton to use in his experiments Newton's gravity. Similarly, charge also defined as the fundamental property of the matter by which it can interact in electric and magnetic fields. That fundamental property we are calling as charge. Once again, the definition of charge is taken as the fundamental property of the matter by which it can interact in electric and magnetic fields. That is the definition of charge, and it is denoted by the letter. So it is denoted by Q. You can use a small q or capital Q, no problem. We can use a small q or capital Q. Like we define mass as a small m. right? Time t, length L, temperature T. Similarly, we define charge of a body is Q, small q or capital Q you can use. Now we are going to learn about the properties of charge. Properties of charge. So far you learnt about definition of static electricity, means what is static electricity, and you learnt what is the definition of charge. Now we are going to learn about the properties of charge. The first point is the SI unit of charge. We should know the units of charge, in that the SI unit of charge. The SI unit of charge is ampere into second. Ampere into second. Or it can be called as coulomb. It can be called as what's a coulomb. So its spell is COULOMB. It is denoted by letter C. So coulomb is the SI unit of charge. And we have other units. So the other units of charge in CGS units are ESU. ESU, or it can be called as static coulomb. What do you call it as? Static coulomb. Or another name for this is Franklin. Another name for this is Franklin. So this Franklin is the smallest unit. The smallest unit of charge is taken as Franklin, sir. The smallest unit of charge is taken as Franklin. And now another unit we have. Before going to that, let us see what is the relation between coulomb and ESU. The relation between coulomb and ESU is 1 coulomb is equal to 3 into 10 power 9 ESU. Understood? 1 coulomb value is 3 into 10 power 9 ESU. And the another unit is EMU. This is also another unit of charge itself. So the relation is 1 coulomb is equal to 1 by 10 EMUs. 1 coulomb is equal to 1 by 10 EMUs. So next there are some other units. These are called as practical units. We call them as practical units. So the practical units are for charge. The practical units are ampere into hour. Ampere into hour. So 1 ampere or is equal to 1 ampere or is equal to 3600 coulombs. Conversion, sir. And another practical unit is Faraday. Right. So 1 Faraday is equal to 1 Faraday is equal to, so 96,500 coulomb. 96,500 coulomb. This Faraday is the largest unit. Faraday is the largest unit of charge. Smallest unit is what, sir? Very good, Franklin. Largest unit is Faraday. What is the SI unit? The SI unit of charge is what? Coulomb. Very good. So just you remember only coulomb, it is enough. So for your information, for your knowledge, I have given other units like ESU, EMU, Faraday, ampere hour, these all things. But just you remember coulomb, it's enough for our study purpose. Right. So second one is the second property is charge is a scalar quantity. Charge is a scalar quantity. So many of you know that what is vector, what is scalar. So scalar is nothing but the physical quantity which has only magnitude. Very good. Right. So charge has only magnitude, it has no direction. It can be added algebraically, so that it is a Very good. Scalar physical quantity, and can be of two types, and can be of how many types, sir? Two types. That also you know, you might have learned in your chemistry, right? Very good. There are positive charge and negative charge. You know that electron and proton. Charge on electron is taken as negative, charge on proton is taken as positive. Very good, remember that. So charge is a scalar quantity and can be of two types. One is positive charge and second one is negative charge. Now coming to third one. Third property is charge is transferable. What is that, sir? Charge is transferable. Transferable means you know the meaning of that. We can transfer from one place to another place. Here coming to charge, it can be transferred from one body to another body. One body to another body. So this is known as charge is transferable. So we can transfer charge from one body to another body. That means, for example, let us take A and B are two bodies. A and B are two bodies. So A is a positively charged body, B is a negatively charged body. A is a positively charged body, B is a negatively charged body. So whenever I put together A and B, I put together, when they are in contact, then what happens is electrons will be transferred. You remember this point, always electrons will be transferred in the conductor from one body to another body. It's a very important point. So that means which has excess electrons? B. Nice, because B is a negatively charged body, means more number of electrons are right. So A is a positively charged body. A has less number of electrons, so that electrons will be transferred from body B to body A. Understood, Nana? Right. This process is known as conduction. What do you call this as? Conduction. So when two charged bodies are in contact with each other, electrons will be transferred from one body to another body. This process of acquiring charge is known as conduction process. So this is the third property, charge is transferable, means we can transfer charge from one body to another body. So the charge transformation taken place by the help of electrons only. Only the electrons will be transferring from one body to another body. Which has more electrons, that body lose electrons, and for the positive body is going to gain electrons. Clear? Right. And let us see another property. Fourth one is charge is always associated with mass. What is that, sir? Charge is always associated with the mass. Means let us take electron or proton. You know that electron has a mass and proton has a mass. You know that. What is the mass of electrons, sir? Very good. 9.1 into 10 power minus 31 kg. What is charge on electron? Electron charge 1.6 into 10 power minus 19 coulomb. Same charge of proton. Proton and electron. Charge on proton and charge on electron are equal. Right. So this sign, negative sign and positive sign, is just convention. Okay. The magnitude on electron and the magnitude of charge on proton are same. Okay. No one is bigger, no one is lesser. Both have same. Okay. Now charge cannot exist without mass. Remember this point. Charge cannot exist without mass. But mass can exist without charge, sir. Let us take this pen. This pen has mass, but now it has no charge. No charge means neutral, the number of electrons and number of protons are equal, that it is called a neutral body, you know very well. Okay, so this is next one. Yeah, next one is the fifth property. Charge is quantized. Charge is quantized. So what does it mean? Charge is quantized means what? So here you remember quantized means quanta, you might have learned this word. It means that charge cannot take any value, but the value are that are integral multiple of fundamental charge. So first, what is fundamental charge? Fundamental charge is taken as a charge on electron, that is 1.6 into 10 power minus 19 coulomb is taken as a fundamental charge. Any body which is a charged body, whether it is a positively charged body or a negatively charged body, will be multiple of this E, means fundamental charge. Means, for example, charge on a body is a Q, this Q will be integral multiple of E. This is the meaning of charge is quantized. So Q is equal to N into E, where N is a number, it can take 1, 2, 3 etc. values, but N cannot be like 6.5, okay, and N cannot be the powers 10 power minus 5 minus 6 like that, and N cannot be fractional numbers 5 by 6 etc. Okay, these numbers cannot be included. So that the charge is quantized, N will be taking the values of 1, 2, 3. So charge on the body always the integral multiple of the fundamental charge. Remember that charge on a body is always equal to the integral multiple of fundamental charge. Okay, let us see that. For example, body A has 10 electrons and 8 protons. 10 electrons and 8 protons. What is the type of the charge on the body? Is it positively charged body or a negatively charged body? Very good. It is a negatively charged body, because number of electrons are greater than number of protons. So 8 protons, 8 electrons are balanced their charge. 2 electrons are excess, so that the charge on A is negatively charged body. So how much is the charge on this? Use the equation Q is equal to Ne, that is N is how much, sir? 2. Excess number of electrons or excess number of protons we will be taking as N. So here excess number of electrons are 2, so 2 into what is the fundamental charge? 1.6 into 10 power minus 19 coulomb. So if you calculate that, you will be getting 3.2 into 10 power minus 19 coulomb is the charge on A. Simply we can say that charge on A is negative, and what is the magnitude of the charge? 3.2 into 10 power minus 19. In this way, by using this relation, this equation, you can calculate charge on the body if you know how many electrons and how many protons are there in the body. So if protons are more than electrons, then it is called as positively charged body. Means if a body lose electrons, it becomes a positively charged body. If a body gains electrons, it becomes negatively charged body. So if the number of electrons and number of protons are equal, it is a neutral body. Once again, if the body lose electrons, it becomes positively charged body. If a body gains electrons, it becomes a negatively charged body. Electrons and protons are equal in number, it is a neutral body. Very good. Now tell me whether a body lose or gain electrons, does its mass changes? Does the mass of a body changes during charging it, means whether it is positively charged or negatively charged. Let us see that the mass of the body changes or not. For example, in this example, so if it is a neutral body, 8 protons and 8 electrons should be there, right? So now it is a negatively charged body, 2 electrons are more in number. Then how much mass is more? 2 times of mass of electron. That means now body A gains mass because number of electrons are more here. That means negatively body gains mass, positively charged body lose mass. Clear? Any confusion? Positively charged body means what? Loses electrons. Means electrons are going from that body, so that electrons has mass, so its mass is decreasing, so it is losing mass. Clear, sir? So negatively charged body gains mass. Okay, positively charged body lose mass. Clear? Right. So this is the concept behind that. Next, sixth property is charge is conserved. Charge is conserved. You might have learned this word conserve, conservation of mass. Mass neither be created nor be destroyed. Similarly, conservation of energy. So here also we cannot create charge, we cannot destroy charge, but can be transferred from one body to another body. Can be transferred from one body to another body. This is called conservation of charge, right? No. Okay, next one is next property is charge is invariant. What is that? Charge is invariant. What does it mean? Charge is invariant means the value of charge will not change. The value of charge, the magnitude of the charge will not change depending on its state. Means whether it is in the state of rest or whether it is in the state of motion, the charge is same. The amount of charge on the body is same, but mass will change. So according to Einstein's theory of relation, so it's another matter, right? Here charge is invariant. Charge will not change. Charge, the amount of charge will not change when the body is at rest or in motion. Next, the eighth one and important one, and you know very well, this is loss of charged bodies. Loss of charged bodies. So in this there are two. First one is like charges repel each other, sir. Like charges repel each other. What does it mean? For example, if you take a positively charged body and another positively charged body, these two bodies will push each other. This body push this side, this body push this side. This is called repulsion. Okay. Similarly, if you take negatively charged body and negatively charged body, they will be pushing each other like magnets. You learnt in magnetism. Yes, exactly. And second law, can you guess it? Very good. Unlike charges attract each other. Okay, if it is positive and negative, then they attract each other. Okay, pulling towards each other, right? These are called laws of charged bodies. Laws of charged bodies, right? And one more thing is here, the important thing is surest test of electrification is repulsion. What does it mean, sir? It means, for example, you might have learned in magnetism, if I give a magnet bar and the same kind of another bar I have given, and you have to know that whether this bar is a magnet or not. So in that case you learned surest test of magnetism is repulsion. Similarly, surest test of electrification is also repulsion, right? And next one, the ninth property is charge resides on the surface of the conductor. Where's on the surface of the conductor? Always charge resides on the surface of the conductor. Remember this point, Nana. That means if I say charge of the body positive or charge of the body negative, no, I should say charge on the body is positive. So this charge resides on the surface of the conductor. Charge on the body is negative. I should use on the body, not of the body. Clear? So always the charge resides on the surface. It's experimentally proved. Okay, so the next thing we are going to learn is that about how can you calculate charge on the body. How to calculate charge on the body. So I have given in the previous example that charge on quantization. So we can calculate charge on the body by using a equation called Q is equal to NA depending on the number of excess charges. N is number of excess charges you will be taking and E is the fundamental charge. You will be multiplying and you will be getting the charge on the body. Okay, so now let us learn how to charge a body. Let us go to the topic, how to charge a body. Charging a body, simply we can call as charging a body. So far you learnt the different properties of the charge, sir. Different properties of the charge. Right. So far you learnt different different properties of the charges. Okay. So once again recall all the properties what you have learned so far and what are the units of charge you learned so far. Once recall that. Now we are going to learn another topic called charging a body. So how to charge a body positively or negatively. Okay, so we know that if a body loses electrons it becomes positively charged body. If a body gains electrons it becomes negatively charged body. Then how to take out electrons from the body or how to add electrons from the body, that is called charging methods. So a body can be charged by using three ways. In any one of these three ways we can charge it. One is by conduction. Already we learned this. Okay, next one is by induction. I'll explain this word. And by friction. This also you know very well. I'll explain these three methods one by one. Let us see that. Okay, right. First, conduction. Charge by conduction. So you know by conduction how to charge a body. So we have seen that we took two bodies A and B. One is a positively charged body and another one is negatively charged body. So just you kept body A and body B in contact here. See that? This is a positively charged body, negatively charged body. When you kept these two bodies in touching with each other, electrons will be transferred from one body to another body. Electrons will be transferred from one body to another body. So this kind of electrification we are calling as conduction. This kind of electrification is known as conduction. So what is induction? By second method is what I said, by induction. What is this actually? So in induction method what we are doing is, first we will take a charged body, whether it is a positively charged body or negatively charged body. I have taken a positively charged body. A is a positively charged body and another one is a neutral body I have taken. B is a neutral body, means number of electrons and number of protons are equal in this. When you bring B near to A, listen carefully, near to A, not touching A. When you bring near to A, what happens is the electrons in B will be attracted towards A, and the electrons will be aligning in this way, and the protons will be aligning the other side of the B. This will happen. This is step 1. And step 2, what we are doing is, I am not changing this body. Just when it is in this case, just you connect this body with the help of a conductor to the earth. To earth. This is called earthing. Then what happens? Exactly. Okay, so the electrons will be transferring to the body B from the earth. Then it becomes finally a negatively charged body. In this way, a body can be charged by the method of induction. Clear, Nana? Right. And the third one is what? By friction. Everyone knows this. By the method of friction, means rubbing two bodies with each other. When you rub a comb with the dry hair and bring near the pieces of paper, the pieces of paper will be attracted towards the comb. This is called electrification by the method of friction. These are the three methods which you can use to electrify a body, either positively or negatively body. Clear? Right. These are the methods of charging a body. Next thing is, I have a body. For example, I have a body. That body I gave to you. Now the question is, you should tell me whether the body is a positively charged body or negatively charged body. Understood my question? I have a body. I gave you that. Now tell me whether it is a positively charged body or negatively charged body. So for this, what we should do? So we should use a tool to do this. That tool is known as gold leaf electroscope. We call that as gold leaf electroscope. By using this gold leaf electroscope, we can identify the type of charge on the body, whether the body is positive charged body or negative charged body. So how it looks like? So the structure of the gold leaf electroscope is in this way. So it has a glass jar. In this glass jar, a conduction rod is kept. It's a conduction rod. At the end of the conduction rod, there will be gold leaves. These are the gold leaves. It is tightened with a rubber cap. This is called gold leaf electroscope. Okay, right. This is a conductor and these are the gold leaves. So what? So first, if you want to test whether a given body is positively or negatively charged body, first you should charge the gold leaf electroscope. So how to charge that gold leaf electroscope? You can charge it positive or negative. So I want to charge the gold leaf first positive. How? So if you want to charge it positive, what you should do? You should take out the electrons from this rod, then it becomes positive. To take out electrons from this body, what you should do? Just you bring a positively charged body and keep it here. Then what happens? Yes, electrons will be transferred to this. Then this whole thing will be positively charged body. Then what happens is, this will be the situation. The gold leaves will be diverging. What is the reason? Yes, these are positively charged gold leaves. These are all positively charged body. So as this leaf is positive and this leaf is positive, they repel each other and they diverge. Okay, now it is a positively charged gold electroscope. Okay, gold leaf electroscope. Now you bring a unknown body near this. Okay, two possible cases will happen. One is the gold leaves diverge more. Listen carefully. And second thing is the gold leaves will collapse. So I will explain one by one. If the gold leaf are diverging more, means they are moving far away. What does it mean? It means the positive charge is increasing on them. When the positive charge increases on them, electrons should go to this body. If electrons goes to this body, what does it mean? This is a which kind of body? Positively charged body or negatively charged body? It is taking electrons, means it is a positively charged body. Very good. So that means if they diverge more, okay, the unknown object is positively charged body. In this way you can identify. What happens? Second thing, now instead of diverging, they collapse. Means collapsing means they fall in this way. What does it mean? When they collapse, when they gain electrons, they become neutral and false. They are gaining electrons means it should have more electrons, means it should be a negatively charged body. Understood, sir? In this way we can identify the given body is positively charged body or negatively charged body. If the positively charged gold leaf electroscope diverges more, the unknown body is positively charged body. If the positively charged gold leaf electroscope leaves collapse, then the unknown body is negatively charged body. Very good. So this is about charge now, only about charge. So next thing will be Coulomb's law. So in next class we will be learning that. So meanwhile I will upload a worksheet for this topic. I will give that link in the description of this video. So from the description of the video you can download that worksheet and practice it. And the second thing, so the classwork papers on what I have written, these all things will be uploaded, and that link also I will be providing in the description of the video. Next point, listen carefully this point. If you have any doubts on this video, just you note down all the doubts and in the comment section of this video you post those doubts. I'll check all the doubts and I'll make a video for all these doubts. And finally my request is, if you like this video, yes, if you like it, press like button and share it to your best friends so that they also learn something. And do not forget to subscribe, because if you subscribe, whenever I upload a newer video, first you will be intimating that and you can watch it. So subscribe, like and share. Thank you very much.